Hello, welcome to Project 1 of our Electronic Engineering Kits series, Powering an LED. In this video, we'll be covering how to use an Arduino Nano to turn on an LED. To do this project, you will need one Arduino Nano, one breadboard, two male-to-male jumper wires, one 220 ohm resistor, and one LED. This project is intended to teach you about Arduino Nanos. An Arduino Nano is a small microcontroller board that allows you to take inputs like sensor values or the press of a button to produce outputs like electricity at various voltages. You'll learn more about this device in later videos and as we practice more and more. You'll also need to use and understand breadboards. Breadboards are small plastic boards with metal clips underneath that allow you to create circuits quickly and easily without permanent solutions. To use this, all of these holes are connected in rows. For example, this row is all connected. So if you have power going into one of these holes, then there'll be power going to all of these holes, and it's important when developing our circuits. This is the case for every single row here and here. On these rails, this negative and positive rails are also connected as well. Here, all of these holes on this negative rail are connected. So if you place a wire here and a wire here, they'll still be connected. And this is the same with the positive end. All of these holes are connected. Although it says positive and negative, there really is no positive or negative current going through it. And it doesn't matter too much, but it's good for organization purposes. One component you'll learn more about in future videos is the resistor. It helps to limit current and protect components of our circuit, like the LED. LEDs can only have a certain amount of current going through it, and so using these resistors help to protect it from breaking. One component we should understand is the LED, or light emitting diode. It has two main components, the longer end, which is the anode, and the shorter end, which is the cathode. The anode, or the longer end, is where we're applying power, and the shorter end, or the cathode, is the ground of the LED. Now, let's create our circuit. First, we want to take our Arduino and place it on our breadboard using these prongs. Make sure the USB-C port is pointing outward to make it easier to power our circuit. When we're placing it on our breadboard, it will be slightly uneven. There'll be 3 holes on one end and 2 holes on the other. It doesn't really matter too much. Next, what we want to do is place our LED onto our breadboard. What I like to do is have the shorter end, or the cathode, on my left-hand side, and the longer end, the power and the anode, on the right-hand side, just for consistency purposes. Now, let's place our resistor. We want to first take this straight line and bend it to make it easier to place in our circuit. And we want to connect this to the ground or cathode of the LED. I like to place it on this negative rail here because of how many holes there are, and it makes it easier to then connect our ground, which we will do next. Normally, we use dark colored wires. In my case, I have blue as my ground wire. So here we'll connect the ground of the LED, which is flowing through this resistor, and connect it to the ground of the Arduino here. Make sure that you're pushing in all of your components all the way to make sure they're connected. Now we'll take our light colored wire and apply the power. Here we can take one end of the LED and place it on plus 5V, or plus 5 volts. Here the Arduino is outputting 5 volts, and so we want to use that to power the anode of the LED, or the longer end. So we'll place that on this row. To explain it a little further, what we have is we have power coming from 5 volts going into the power of the LED, which is then flowing into this ground, which goes through the resistor and then into the ground of the Arduino, which completes our circuit. Now let's power our circuit and see what happens. Here I'm using a USB-C wire and a power bank, but you can use your nearest outlet. Now, when we plug it in, the LED should light up. Congratulations, you've completed your first project in the Electronics Engineering Kit series.